Dear learners, a very warm welcome in the MOOCs of Emerging Technologies in Energy Sources, and the module that we are going to discuss is tidal energy resource. I am Dr. Shweta Tripathi, Assistant Professor in Mechanical Engineering from School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. The learning outcome of this module is to understand the concept of tides and tidal energy, to discuss various techniques used in conversion process of tidal energy into electricity, to understand the working of various turbines that are used in tidal power generation, to discuss the advantages and limitations of tidal energy. Tidal power. Tidal power is a form of hydropower that converts the energy of tides into useful forms of power, mainly electricity. So, this is the only form of energy whose source is the moon. Why? Because the tides are caused by the gravitational pull of the moon and sun and the rotation of the earth. So, the tidal energy is the utilization of the moon and sun's gravitational forces. As tides are formed by the gravitational pull of the moon and sun on the oceans of the rotating earth. So, this gravitational pull of the sun and moon and the pull of the centrifugal force of rotation of the earth moon system is utilized here. There are two high tides and two low tides. So, generally two types of tides are there, high tide and low tide. So, during each period of rotation of the earth, there are two high tides and two low tides. Spring and neap tides depend on the orientation of the sun, moon and the earth. Actually, these high spring tides occur when the sun and moon line up with the earth, and this occurs whether they are either on the same or opposite side. Low neap tides occur when the sun and moon line up at 90 degrees to each other, and flood currents are the currents moving in the direction of the coast, and ebb currents are the current receding from the coast. So, when a landmass lines up with the earth moon system, the water around it is at high tide, and when a landmass is at 90 degree to the earth moon system, the water around it is at low tide. So, some important terms are flood current, ebb current, neap tide, high tide, low tide, spring tide. So, these are some of the important words that we are going to use in this particular session. I hope you understand all of these terms. So, if we talk about the tidal plant facilities, two types of tidal plant facilities are there. One is due to the tidal barrage and another is tidal current turbines. And these, with the help of these two, we can make the tidal power plant, dynamic tidal power plant. So, what is tidal barrage? Actually, the tidal barrage generally utilize the potential energy. How and why? These tidal barrages are the dams generally, which are built across the entrance to a bay or estuary that capture potential tidal energy, similar to tidal lagoons. Energy is collected when the height difference on either side of the dam is greatest at low or high tide. So, generally we are generating here the energy through the difference in the heights. So, we are utilizing basically the potential energy. A minimum height fluctuation of 5 meter is thought to be required to justify the construction. So, only 40 locations worldwide have been identified as feasible. Similar to low head hydroelectricity production is achieved by coupling generators to the turbines. Now, the advantages are that the mature technology that has been around for nearly 50 years it is a reliable energy source. And limitations are high cost of construction, environmental impacts will be there on marine life, and the power output is very low in comparison to other energy sources like coal, nuclear power plant, hydropower plant. So, power output is very low. Generally, two types of plants are there: single basin system and double basin system. Now comes the tidal lagoons. Actually, these tidal lagoons are comprised of retaining walls embedded with reversible low head turbines that enclose a large reservoir. The rise and fall of tides cause a difference in the water height inside and outside of the reservoir, where a pressure differential drives a turbine similar to a conventional low head hydro dam that works in both directions. The electricity production is achieved by coupling generators to the turbines. Now, ebb generation and flood generation. During flood tide, basin is filled and sluice gates are closed and trapping water. Gates are kept closed until the tide has ebbed sufficiently, and thus turbines start spinning and generating the electricity. During flood generation, the basin is filled through the turbine which generate at flood tide. Two-way generation sluice gates and turbine are closed until near the end of the flood tide, when water is allowed to flow through the turbines into the basin, creating electricity. At the point where the hydrostatic head is insufficient for power generation, the sluice gates are opened and kept open until high tide, and after this high tide they will be closed. When the tide outside the barrage has dropped sufficiently, water is allowed to flow out of the basin through the turbines, again creating the electricity. Now the double basin system. In this double basin system there are two basins, but it operates similar to an ebb generation single basin system. The only difference is a proportion of the electricity is used to pump water into the second basin, which allows storage as well. The current sites of tidal barrages are Lawrence, Brittany, France. The first and second largest tidal barrage power plant, two-way generation system and pumped storage is available at Annapolis Tidal Generation Facility on the Bay of Fundy, Canada. Further development is being considered in the Bay of Fundy as well. Now comes the tidal current turbines. They make use of kinetic energy of moving water to power turbines in a similar way to wind turbines that use the motion of wind to power turbines. They operate during flood and ebb tides. It consists of a rotor, gearbox and a generator, and these three parts are mounted onto a support structure. There are three main types: gravity structure, piled structure and floating structure. Gravity structures. So, these gravity structures are massive steel or concrete structures attached to the base of the units to achieve stability by their own inertia. Piled structures, they are pinned to the seabed by one or more steel or concrete piles. The piles are fixed to the seabed by hammering if the ground conditions are sufficiently soft, or by pre-drilling, positioning and grouting if the rock is harder, depending upon the rocks. Then floating structures. They provide a potentially more convincing solution for deep water locations. Now the dynamic tidal plant. Dynamic tidal plant is a new and untested method of tidal power generation. It would involve creating large dam-like structure extending from the coast straight to the ocean with a perpendicular barrier at the far end, forming a large T-shape. A single dam can accommodate over 8 gigawatt of installed capacity. The dynamic tidal plant dam is a long dam of 30 to 60 km which is built perpendicular to the coast, running straight out into the ocean without enclosing any area. Other concerns include shipping routes, marine ecology, sediments and storm surges for developing this kind of dynamic tidal power plant. Now if we learn about the helical turbine or the basic concept of helical turbine. Here it is designed for a hydroelectric application in free flowing water. It generally operates in ocean, tidal and river currents, and it does not require expensive dams that can harm the environment. So if we talk about the features of this helical turbine system, self-starting with flow as low as 0.6 meter per second. So slow rotation should be there. Running is very smooth, rotation in the same direction regardless of the direction of flow, making it ideal for tidal applications. Why? Because the slow rotation implies coupling to a generator through a gearbox only. So the system is very simple. Now the types of tidal steam generators. Actually, modern tidal power plant generating turbines operate on the same principle as wind turbines. As the moving water passes the current turbine's blades, the current's kinetic energy is converted into mechanical energy as the rotating blades spin a drive shaft. So this mechanical energy in the drive shaft is then converted into electrical energy using a generator. This is generally done often through a gearbox. So some tidal steam generators are immature technology. No standard technology has yet emerged as the clear winner. But for a large variety of designs have been experimented, and some are very close to large scale deployment also. So tidal turbines typically operate in restricted passages that limit the height and width of the turbines. Generally, two primary archetypes have been developed that have direct analogues in wind energy: axial turbine, and second one is vertical and horizontal axis cross flow turbine. So if we talk about the axial turbines, these turbines are the mostly similar to the traditional wind turbines, where the kinetic energy of moving water is captured by spinning blades facing the direction of flow, and the turbines can be open or ducted. Ducted means shrouded, and they can be placed anywhere in the water column, although the bottom mounted is the most common. Turbines may use active or passive measures to yaw or wane in the direction of flow. They can have pitching blades, allowing them to change their hydrodynamic performance based on flow conditions. As for wind turbines, a number of different electrical generation options may be selected for electricity production, from permanent magnet machines to induction generators, which are directly tied to the grid. These are close in concept of traditional windmills operating under the sea. Now vertical and horizontal axis cross flow turbines. These turbines capture kinetic energy of moving water with spinning blades oriented perpendicular to the direction of flow. They can be mounted in either vertical or horizontal orientations. When mounted vertically, these devices can operate regardless of the direction of the flow. They typically have cylindrical cross sections amenable to placement in confined channels or allowing tight array spacing. Turbines can be open or ducted and placed anywhere in the water column, though bottom mounted is the most common, and the electricity production mechanism is similar to axial flow turbines. This we have already discussed. Now the reciprocating devices. They do not have rotating blades, but instead have one or more hydrofoils that translate perpendicular to the flow direction by left or drag. They may be oriented horizontally or vertically, though like axial flow turbines must face the direction of flow for maximum energy extraction. And the oscillating devices are the most common form of reciprocating devices. Here the linear motion of the foils may be converted to rotary motion for electricity generation, or linear generators may also be used. Now the advantages are that they are able to utilize both ebb and flood tides, and tidal current turbines are not large massive dam, do not need large massive dam structure. And limitations are, tidal current turbine technology is very young in its development. Installation and maintenance are again a challenge. Then environmental impacts are still being tested. So these are why we are not utilizing it, or they are still in the development stage. Now if we talk about the environmental friendliness of conversion of this tidal energy, the tidal energy use involving dam creates many of the same environmental concerns as damming rivers. Tidal dams restrict fish migration and cause silt build-up, which affects tidal basin ecosystem in negative ways. Systems that take advantage of natural narrow channels with high tidal flow rates have less negative environmental impact than dam systems, but they are not without environmental problems. Both system uses turbines that can cause fish kills, but these are being replaced by new, more fish friendly turbines. The art and science of environmentally friendly hydroengineering is well advanced and will certainly be applied to any tidal energy project also. But even with dams, the environmental impact of tidal energy projects may prove to be smaller than our use of any other energy resource. Economics will severely limit the number of tidal energy projects. Now the tidal, as we have started discussing about the economics of tidal energy, we can say that it is not a cost competitive. Why? Because it is generally not commercially available also. When selecting a spot to set up a tidal energy station, it is important to make sure that it will be economically feasible. To set up a tidal facility with an average annual output of 1050 megawatt would cost about $1.2 billion, not including the maintenance and running costs here. It is far more expensive than coal and oil. So these are the reasons why this kind of technology are still in development stage. Now what will be the future of this kind of technology? In a society where the energy need is increasing day by day, it is becoming more and more important to have alternative sources of power to keep up with the ever growing energy demand. The capacity of tidal energy exceeds that of coal and oil and is renewable. So the Department of Energy has shown great enthusiasm in regard to the tidal power as a perfect energy source for the future. If we talk about the tidal plants that are available in India, so West Bengal Renewable Energy Development Agency in Sundarbans has developed some of these plants. The Indian state of Gujarat is planning to host South Asia's first commercial scale tidal power station, and the company Atlantis Resources is to install a 50 megawatt tidal farm in the Gulf of Kutch on India's west coast, with construction starting early in 2012. Later on, it is decided to increase the capacity to 250 megawatt. Then tidal plants in Kerala are situated near the breakwaters of Vizhinjam port, which is about 20 km from Thiruvananthapuram city. The station started its commercial operation in 1991, and this oscillating water column produces about 150 kilowatt of power. Now, advantages and limitations of tidal power. So, generally the advantages are they do not require any fuel. The economic life of tidal plant is about 75 to 100 years, while conventional fossil fuel plants have life of about 35 years only. This is a clean and renewable energy source. It is non-polluting, and a tidal barrage can prevent approximately 1 million ton of carbon dioxide per TWh generated. Disadvantages: tidal energy affects the ecosystem, and tidal energy leads to damage like reduced flushing and erosion, which ultimately affects the vegetation of the area and disrupt the balance also. The alteration of tidal currents also affects the habitat of the seabirds and the fish. So, in this particular session, we have discussed about the tidal energy. Like other renewable energy resources, tides are also an alternative energy resource for generation of power. We have discussed in this particular session that how the tides are formed. Basically, the tides are caused by the gravitational pull of the moon and sun and the rotation of the earth. So, basically three forces or three things are involved for the formation of tides. One is gravitational pull between the moon and sun, another is the rotation of the earth, and then the third thing is how we are going to utilize this thing. Tidal energy is the utilization of the moon and sun's gravitational forces. And near shore, water level can vary up to 40 feet due to tides. So, if we talk about the flood tide, which is the tide that is coming in or rising during the rising, and ebb tide, which is one that is going out. So, we have to utilize both of these tides. We have discussed that how many ebb tides are there, how many flood tides are there. We have discussed the various keywords that are related to these tides, how the tides will form, how they will form, how we are going to utilize the energy from these tides. So, this tidal energy takes advantage of the daily tides, daily ebb tides, and the flow of these tides also. The gravitational pull of the moon drives tidal flows. So, basically the power that we are going to generate depends upon the flow of these tides, and they depend upon the gravitational pull. We have discussed that how the energy of these tides, which is mainly hydropower, could be utilized in production of electricity. In hydropower, we utilize the potential energy of water by building the dams, etc. Here also we are building the dams. What are tidal barrages? They are the dam only. So, we are building the barrages and we are utilizing the potential energy of the water here also, but here the distance is lower, and in the case of hydropower the distance means the height of the dam is higher, but here the distance in which we are building the dam or we are building the barrage is more. Here we are building the barrages of 30 to 60 kilometers. That is over the coastal area from one part to another. So, it is about 30 to 60 kilometers. But in case of hydropower generation, we do not build such long distance dam. So, here the distance is larger, there the height was larger. So, if the height is larger there, that is the height from the reference is higher in case of hydropower generation. So, here the power will be more, while in case of tides the height is not that much, so it is smaller as compared to hydropower. they could be comparable to the small hydropower generation systems. We have also discussed about the various technologies that are used for the conversion of tidal energy. We have discussed about the tidal barrage, lagoons, we have discussed about the turbines, helical turbines, we have discussed about the conversion of kinetic energy of these tides into electrical energy as well. So, when we are utilizing the kinetic energy for the generation of tidal energy, this kind of technology is similar to the technology that is utilized for generating the power from wind energy. So, the technology that we are adopting for generation of tidal energy is similar to hydropower also and to the wind power energy also. For hydro, when we are utilizing the potential energy of the tides, it is similar to the hydropower, and when we are utilizing the kinetic energy of the water, it is similar to the wind power system. So, here for utilizing the kinetic energy system, we are utilizing axial turbines and horizontal turbines for the generation of the power. Apart from this, we have also discussed the concept of helical turbine, why it is important, how it is important, how we are going to utilize it. We have also discussed the various advantages and disadvantages of tidal power plants and their future as well. Future means how we are going to utilize this tidal power energy for the future. We agree that the power that or the potential of the tidal energy in India is lower, but when we are at the verge of developing the alternative energy resources, we have to look forward for all the opportunities that are available. We know that nowadays the world is confronted with the twin crisis. One is fossil fuel depletion and another is the environmental degradation. So, here in the case of tidal energy, the environmental degradation is lower because it is not emitting any kind of harmful gases, etc. So, only the environmental degradation is in the form of the losses into the water. So, no environmental degradation is there, it is an eco-friendly thing. Only the making of dam, etc. can hamper some of the species. So, this is not that much that is done by other renewable energy resources. So, this is why we have to look forward for tidal energy also for the future prospect of India. Thank you very much.